Alright, hi everyone. Hope you are doing okay. I'm just doing fine. Today we will cover data in C++. And actually, in any programming language, we have two important entities. The first one is data, and the second one is um, instructions. And with the help of these instructions, you can manipulate the data that you have. For instance, let's say you have a unsorted array, and then with the help of these instructions you sort this array, and then you have the final result that you are looking for. So we have two important entities, data and instructions, and today we will discuss data from different angles. The first part that we will cover, and this is the focus of this tutorial, is types of data in C++. And then next tutorial we will explore two important data types like pointers and references, and different scopes of variables that we have, different scopes of data that we have in C++ is the next topic. Then we will go to dynamic allocation, the different ways that you can allocate data and store them on the memory that you have in your computers. And finally, we will see how can we pass data to functions and later receive the data from functions. And all of these topics are completely intertwined and related, and it is expected that you first go through all of these topics and later be able to understand all of the details. So if you are, for instance, struggling to understand the necessity or concept or syntax of pointers, first go through all the playlists, and then watch the pointers and references tutorial again. Then you would be able to understand all the concepts completely. Alrighty, let's go and discuss different data types that we have in C++. Um, by the way, this picture is taken from the internet, and it shows that we have three different categories of types in C++. The first one that you already know is built-in data types like int, char, void, and float, double. But void is not used for data directly. It is used for the return type of a function. If function is not returning anything, we use void. And the next level is derived data types. We have arrays, functions, pointers, and references. I will record another video to explain how a function can be a data type, and also we will cover pointers and references in depth in another tutorial. And in this tutorial we will completely cover arrays as a data type, as a derived data type. And the next category is user defined types like a structure, union, class, and enumeration. Union and enumeration are not used frequently, but classes and structures are used frequently, and the focus of this course is class, and how it is that we are switching from procedural programming to object-oriented programming, uh, and we are using how can we use objects and how can we define classes. Yep. All right, so let's go to the coding part and see how can we declare, initialize, and use these data types. The first part, as I said, is primitive data types or built-in data types, like integer, float, char, boolean, double. And this is how you can, let me zoom actually a little bit. This is how can you initialize all of these primitive data types. integer, double, char, and bool are keywords, and then you can use equal sign to initialize them. And also true is a key, true or false is a keyword in C++, which means true or false. They are binary values. And yeah, there is nothing strange or complicated here in this part. And then you can simply print them cout with cout if you want, binary and del. And so let's print this part to see what will happen. And before that, I will comment the rest of the program so that we don't get the print result of the rest. Yeah, you see, when I print the binary value and it is false, it will print 0 for me. And yeah, that's it. Let's go to the next part, which is user-defined types. I will start with unions because it's the most simplest, and we don't really need to use unions frequently. Unions are a common place for storing different attributes, different data types. For instance, if you are deciding to store a height of a person, you have different options. You can store in centimeter and ignore the floating part, or you can store in centimeter and have the floating part, or you can also use feet instead of meter or any other measurement. And the thing is, only one block of memory is allocated for storing all of these attributes, and the block of memory that is stored is has the size of the largest data type that we have. For instance, int requires 4 bytes, but float requires 8 bytes or maybe 16, I'm not sure. But so when you create an instance of height, it goes to the memory and it reserves 8 bytes for you, and you can store the height either in centimeter and use only 4 bytes. For instance, you can store 180 centimeter here in this block in the first 4 bytes, or you can use the whole allocated memory and store the height in feet. Like you can store 5.9 feet here in this memory block, and they will overwrite on each other. If you have already stored the height in centimeter and later you decide to change your measurement and use feet for storing the height, you will overwrite on the data that was previously stored in this block of memory, and it is shared. We don't usually use unions in C++ anymore, but yeah, for the sake of completeness, I brought I brought examples of all different data types that we have in C++, but we don't really need to use unions anymore, or at least it's not common. And one way for creating an instance or a variable of this union type is you can either, after closing the curly bracket, after finishing the definition, you can write the name of your variable that you are going to create, and this variable would be global. Or you can later in your code create an union. Let me unblock this part. All right. So right now I will use hg, the instance of the height that I created here before the main, and then pass 180 to that, and it will use the four bytes of the memory to store 180. And when I print that with hg.centimeter, it will print 180 for me. And later, if I change the height to another measurement and use feet instead, and use the equivalent number of feet, which is for 180 centimeter, which is 5.9 feet, it will store this exactly on the same block of memory that is allocated for hg union. And obviously I will lose access to this hg.centimeter. So the thing is, the purpose of using union in C++ is saving memory when you have different options, but only at any specific time only one of them is active, and you are only using one of them and not more. So this is how you can manage and save memory. But if you need more information, you can use this. You can read this article. And yeah, right. Next user-defined type is enumeration, enum. Enumeration is when you have a list of attributes and they are not numerical, but you want to assign a numerical value to them, you can use enumeration. And it is by default, when you define an enumeration, all of these values are enumerated from 0. And for instance, here the number that is linked to Monday is 0, and then Tuesday is 1, Wednesday is 2, and so on and so forth. And at the end I have created one enum from weekdays, and I have called that today. This is how you can change the value and I have changed the value of today. I have initialized that with Friday, the value of and when I print that today, it should return the linked value, the numerical value of today, which is 0, 0, 1, 2, 3, 4. Yeah, so it should print 4 for me here. And later, next day is the today plus one day, it will print 5. Yeah, that's everything about enum. Enum and union are not really frequently used, but a structure and classes are frequently used, and classes actually basically are the focus of this course and the rest of the tutorials that we have. About the struct, it was firstly introduced in C language, and you could group different data and use them and group different data. But for instance, here we have a person struct, and I'm bundling different attributes, different data, which creates a person for me, which creates a person structure. For instance, a person has a name. By default, it's not given, and then person has an ID. It's double. It should be practically it should be int, because in ID is int usually, not double, but anyways. And then I have created two instances of this structure, P1 and P2. Later, here with dot operator, I can get access to different attributes of person 1 and change that. And then person 1 ID, I can change that to another ID. and simply print them with dot operator. But later in C++, struct syntax and usage was developed, and you can right now bundle both data and instructions and functions. For instance, you can exactly copy and paste all of these instructions, all of these lines of code in here, and have the exact behavior as a class of a student. So, but initially, a struct was introduced for bundling and grouping different data together that are representing a single a structure or um, single entity. All right, this is all about the structure, and the last one, the last user-defined type is class. For class, we can bundle both we can group or bundle both data and instructions, and also we have different access specifiers, like you cannot easily use dot operator to access all the attributes or all the functions anymore. If this is if an attribute or a function is private, you cannot use dot operator to access them. Only the functions that are written here can access private attributes or private functions. But if anything is public, you can simply use dot operator to access them. All right, I have created one student, one object or variable from a student class, and later here in the code I'm using std.setID and GPA. And by the way, I have two functions here for a student class: print info, which prints the info of that student, print the ID and GPA, and set ID GPA, which gets an ID and GPA from a user, and then set these values and change the default value that we have here. All right, I will first for the student one set GPA and ID and GPA to 1 and 4, and then print them, and later I will declare or create another object. I will call that a student 2. But the difference between a student 1 and a student 2 is a student 1 is global, but a student 2 is a local variable. Yeah, that's the only difference. And then again, the same operation. I will change the ID and GPA with dot, and we call the corresponding function, pass the values, and then later print them. All right, let's comment previous codes and run the code again. All right, this is about the union, the first line. I changed that to 180, and then changed that later to 5.9 in feet. And then today is the fourth day, because we are enumerating from 0, and Friday is the fourth element, and the next day, if you add 1, would be 5. And for printing a structure, we can use dot operator to get access to the different attributes that we have, different data, and simply print them. We are expecting that the name of the first person should be person1, as we changed that here, and the ID should be 1, and this is exactly what we are getting here. And about the class, we are changing the ID and GPA here in this line to 1 and 4, and this is exactly what we are getting here. A student with ID 1 has a GPA of 4, and the second student with ID 2 has a GPA of 3.5. which is exactly what was expected. And yeah, that's it. That's the second part, the user defined types. And then next we will see the derived types like arrays, functions, pointers, and references. All right, right now I will cover the syntax of arrays. You already know what is the concept of array, and you already know the necessity of arrays. So I will real quick just cover the syntax of arrays. This is how you can define a one-dimensional array. Int the type of the numbers or the elements of your array, and then 5 is the size of your array. And but if you are defining your you can initialize your array at the declaration. For instance, you can define you can initialize them by 1 2 3 4 5, and if you are initializing them, you don't need to specify the size because the compiler will automatically figure out the size for you. But if you are not initializing the array, you need to pass the size. Here is 5. All right. And you can loop through your array to initialize that also. There is another way for initialization. But the most important thing is C++ compiler doesn't prevent you from going beyond the boundary, beyond the size that you have already specified. Here in the second loop, I'm printing the elements of my array. Let me just run the code one time. The elements of array are 0, 1, 2, 3, up to 4, which is expected. But if I increase the boundary to 10 and I loop through the array from the beginning up to the next 10 elements, the compiler doesn't prevent me, and it will print some numbers. And as you can see, other numbers are nonsense. They are not valid. But you have to, as a programmer, take care of this issue, and you should prevent your code from going beyond the boundary, beyond the size of your array, because you might get an unexpected you will get an unexpected behavior. All right, this was everything about the syntax, and you can similarly define 2D array or 3D arrays and initialize them in this manner. And yeah, that's everything about arrays. About the pointers, this is the first time that we are encountering pointers. So I will first go through the concept, and then probably I will cover the necessity and later the syntax. All right, what are pointers? We discussed that pointers are a type of data, and like we have int as a data type, which means we allocate certain blocks of memory to store the value of the integer. For instance, here we are storing 100. This is the value of our integer, int var. Int var1 is the name of our integer. The value of that is 100, and the address and all of the memory blocks has an address. And the address of the var1 is this 0x123. But pointer is a block of memory that stores an address. So this is the concept behind pointers. The syntax when you are defining a pointer, you will write int, which means what is exactly the type of data that this pointer is referring to, is pointing to. the type of data that this pointer is pointing to is int, because this is this PTR pointer is pointing to a variable var1, and var1 is an integer. All right. So the value of pointer would be an address, and the address of the block of memory that is pointing to, and also the pointer is on a block of memory, and that block of memory has an address as well. This 0x155 is the address of the PTR pointer. So this is the syntax, and we also covered the concept, and the necessity we will cover in the next video. All right, let's go to the code and cover the syntax. First, I have declared a variable called integer number and assigned 7 to that integer. Then I have the declaration of my pointer. This star means this is a pointer, and int means the type of the number that pointer is referring to. And here I have initialized my pointer IPTR to the address of integer number, and the way that I can get access of get the address of a variable is by using ampersand sign. And then I have printed here the value of my integer, and then here the address of my integer, the value that is stored in the IPTR block, this value, and later I am using a star for dereferencing. This star, we are using a star 2 times, at the beginning for initialization and later for dereferencing, for getting access to the data that pointer is referring to. It is called dereference. This is a little bit confusing because we are using a star 2 times for 2 different purposes, and it might be confusing, but you can consider that as a switch that you turn it on and off. And the credit of this intuition goes to one of the students in the class, that he said maybe the intuition behind using a star both for initialization and for dereferencing is they were considering that as a switch, that they can turn it on and then turn it off. Yeah, this. Alright, so let me run the code and see the result. The value of integer is 7, the address of that integer is 0x61 and ends with 98, and the value stored in IPTR pointer is the address, the exact address of that integer num, and the way that the value that IPTR is pointing to is 7. Alright, this was everything about pointers. Next one is references. First, about the concept behind references. References, you can imagine them as an alias, as another name for the variable that you already have. For instance, here in the first line, I am declaring int with ampersand sign, which means the variable is a reference. Iref is a reference to integer num. This means this tells the compiler that whenever you see iref, replace that with integer num. Or in other words, iref is an alias for integer num. They are exactly the same. And compiler, whenever you're using iref in your code, compiler with you can think of that the compiler will replace that with the integer num, with the name and address of integer num. So iref is exactly the same and does does the same thing as integer num. And about the necessity, we'll discuss in the next tutorial. And about the syntax, they can use ampersand to initialize and declare to declare a reference, and int means the type of that value that iref is referring to. And again, for integer num, when you want to print that, you simply use its name ampersand for getting its address, and iref, whenever you are seeing iref, you can replace that with integer num, and it should behave the same. So here the value that iref is referring to, it should be again 7, because the value of integer num is 7, and iref is an alias for that. And again, the value that iref is referring to is also 7, and the address of iref is exactly the same address as integer num that we had. But this is not the case for the pointer that we had. If you print the address of pointer, let me print that here. \n, the address of the IPTR pointer is and get the address again with ampersand sign IPTR. All right. All right, you see the address of IPTR is not the same as the address of integer num. It ends the address of, sorry, this is the address of IPTR. The address of IPTR is 0x61fe98, but the address of integer num is different, 0x61fe9c. You see, this is the address of integer num is ending with 9c, but the address of the pointer is different, is ending with 98. This is exactly what we had here. All of the memory blocks, they have their unique address, but the value that is stored in the pointer IPTR is the address of another variable. Yeah. All right. We covered pretty much everything, and if you need to know the necessity of iReference, and if you want to know more about the concept behind the reference, you can go to this web page and read more. But yeah, so in the next tutorial we will cover pointers and references in depth. And take care, and bye for now.